In this video, I'll be talking about dimensions of some physical quantities in mechanics. And from our knowledge of fundamentals and derived quantities, we know that the basic fundamental quantities is mass, length, and time. And then in this video, we'll be knowing or be understanding how other quantities are related to this physical quantity of length, mass, and time, and then to solve other problems. So let's start with the first one, length. Length dimension is time, and then the unit is in meters. Time is, put it in square brackets, is represented as t, and the unit is in seconds. Then mass and that's m, and the unit is in kilogram. It is in kilogram. Now from this knowledge, let's see how we can dimension other quantities, the derived quantities. Let's start with this one, area. This area is product of length times breadth, and you can write it as length times length, because breadth is also length, and this will give you length L squared. And the SI unit is in meter square. Let's go to another one. Volume. This is a product of length times breadth times height. And then this is length multiplying length. This will give you L3, and the SI unit is in meter cube. That's for one that related with length. And let's check another one. Let's go to density. Density represented as rho. This will give you mass over volume. Mass over volume. And we can understand this to be mass over length times breadth times height. And then from the one we did from here, we understand it to be length times length, so we can do that as rho to be m over L3 which will give you equal that ml minus 3. This is the dimension of density, and the SI unit is kilogram per meter cube. The next one is velocity, which is equal to displacement over time. And this gives you this. Some people will discuss it as distance, but here it's a vector quantity, so it's displacement. Displacement is ascribed with related with length, and this is time. So the dimension of velocity v will give you L t minus 1, and the SI unit of displacement is meter per second. Let's go to acceleration. The next one, acceleration A, small a, is velocity all over time. And velocity from here we see it as L over t. So this will give me L over t all over t. So I'll see it as L all over t squared. So the dimension of acceleration will give us L t minus 2. So that the SI unit of acceleration becomes meters per second square. Let's go to force. Force is a vector quantity. Force is a product of mass times acceleration. This is mass m. Acceleration from here is product. This is velocity all over time. This is mass. This velocity, we got it as, we can jump this step since we have explained velocity here to be Lt minus 1 and acceleration to be Lt minus 2. We can plug this value here to this. This will give you Lt minus 2. So that the SI unit of force will give you kilogram per mass, kilogram length for meters, and then per second squared. And that's for that one. Follow for more. Thanks for watching. In the next video, we'll discuss about how to use this dimension to solve other problems or to find the relation of a particular equation. Thank you very much. If the lecture was helpful and you learned something, subscribe, comment, and share. If you have a problem in physics, both undergraduate and high school or secondary school, let us know in the comment section. We'll give you feedback. Thanks for watching.